Now we move on to changing velocity here. Okay. So let's get going on this. So now what we're going to do here is that we need to add change in velocity. Oh, in velocity. So in order to add change in velocity, here's what we want to do here. So to add change in velocity, we need to plot position versus time for these situations. And what we're going to do here is that we only focus on changing speed, but keeping the direction constant. We do not look at the other situation. And the reason why is that it turns out that we're really starting to look at things where things are rotating in a circle, and it turns out that the algebra is more tedious, and it's better to wait for that to something like chapter 5 or 6. So when I say changing speed, I really only mean that I'm speeding up or I'm slowing down. No turning. So if we go back up here, you could see here is that we were going through, what did I call them? Cases. I did case 1. This is case 2. So now what you're going to find here is that we are now looking at case 3. We're going to be looking at changing velocity. Now, it's worth looking at the motion diagram a little bit better here. And here's what we want to do. Let's think about speeding up here. And at the same time, let's talk about slowing down. What do we know about these guys here? Well, we know this type of thing. We know that if we start looking at speeding up like this, what do we see here? This is 0.0, 1, 2, 3. So if I look at my arrows, what am I actually seeing here? What I'm seeing here is that my arrows are getting longer and longer and longer, right? We're clearly seeing that my speeds are increasing as we go along. But the question is why? It's because of the intervals that we're looking at. We're seeing that these intervals are getting longer and longer. So if you look at my intervals, this is x1. And because this is x1, our speed in this case should be like that. But our next speed here, right here, well, this has a bigger displacement, so its speed is higher. So when I go to this guy right here, you're seeing that this is even larger, which then gives us this higher speed 3 here. So what this picture is telling us is that when I look at let's say delta x1 versus delta x3 here, this is a steeper slope. This guy here is less steep. So what we're looking at here is that we're looking at, so when we're plotting, speeding up, these slopes are changing to steeper values. So if they're changing to steeper values, I'm almost out of time. Let me just draw this one picture just to end it here. Then I'm seeing a picture that looks something like this here. Right here, here's my x of t, and then t. So look how we started at 0. So if I look at my graph, I'm right here. So when I go from my point 1 to point 2, note that, look at the slope of this guy right here. That slope is 0. That's telling me that there's no motion. But then look at x1. Then it moves up just a tiny bit. So when I'm looking at this guy here, you could see that I have just a tiny little bit of delta x. And then I continue to get steeper. And if I look at this guy, you see that x2 is getting bigger. And if I get even steeper here, you can see here that this steepness here is now delta x of 3. That's what we mean by a changing slope. So if I'm looking at the slopes, look at these triangles, how they're getting steeper.